Okay, so we are going to talk about properties of images formed by plane mirrors. Okay, so we have talked about how images are formed in mirrors, in plane mirrors, whenever you have multiple mirrors in the same environment. Now we are going to talk about the properties of images formed by plane what? Mirrors. Now, these are the 5 properties of any image formed. Remember earlier we talked about properties of images formed by pinhole camera. We had 3 of those properties, but now we have 5 properties of images formed by plane mirrors. Now, what are those properties? The first one we said is that the image is upright. Okay, now imagine yourself in front of a plane mirror. Okay, or in front of your mirror in your house. You see that because you are standing upright, your image will also be upright inside the mirror. Okay, so that is what we mean by the image is what? Is upright. So if you are standing this way, your head up, image will also has its head up. So this is the mirror, so the head of the image is also what? Up, just like you. Assuming it was the other way around, let's say the head was down, then we will say inverted, but it is not inverted, it is actually what? Upright. And then again, we said that the image is virtual. When you say that something is virtual, it means that it is not real. Even though when we look at ourselves in the mirror, we see ourselves, we see something that looks like us, but that thing is not real. Okay? It's not real. It is merely a reflection of who we are. Okay, now imagine that you are in front of your mirror and you wave your hand. Your image will also wave its hand. If you come closer to your mirror, the image will also come closer to the mirror. Okay, that is what tells you that that image is virtual. It is there, but it is not there. It is not a real image. If the image was real, it would probably be doing things on its own. So imagine you are in front of your mirror and you say hi and your image says hello. You see, it is not going to be possible. Okay, you will just run away from your house. It is not going to be possible. So that is what we mean by image is what? Virtual. And then the third one, we said that magnification is 1. When we say magnification is 1, it means that if you remember when we talked about pinhole camera, we said that magnification M is V over U, or M is equal to HI over HO. Now what happens? If you remember, M is magnification, V is image distance, U is object distance. Okay, that is what we said. And then HI here is object image height, and HO is object height. Now looking at this formula, if we say that M is equal to 1, so if I put M equal to 1 here and I cross multiply, it means that U will be equal to V. That is what that means. And if I put 1 here and cross multiply, it means that HO is equal to HI. Meaning that if we say magnification is 1, it means that object distance is equal to image distance. Meaning if you're standing in front of your mirror, the distance between you and the mirror is the same distance between the mirror and the image inside the image world. Okay? And then the height of the object is equal to the height of the image. What does that mean? It means that your height as the object is the same as the height of the image that is inside that what? Mirror. That is what we mean by magnification is 1. And then we have image is formed behind the mirror. So whenever you look at yourself, your image, of course, to you, you think your image is inside the mirror. But we don't say image is inside the mirror. We say that the image is behind the what? Mirror. Okay, the behind the mirror we are talking about is not the literal behind, because you might say, okay, if I say image is behind the mirror, if I go to the back of my mirror, I will not see myself there. So my image is not at the literal behind of the mirror, it is inside the mirror, but we usually say it is what? Behind the mirror. That is the term we use. And then the last one is that the image is laterally what? Inverted. Laterally inverted. What does that mean? It means that whenever you are looking at something in the mirror, it is not exactly the way it is in real life. There is an inversion mathematics that is done on that image. So the mirror performs a mathematical transformation on that object and changes it into something else. For example, if I bring a mirror and I write map, you can do this experiment in your house. Just maybe write map on a piece of paper write the word map on a piece of paper and then bring that piece of paper close to your mirror, you will see that that map becomes something else. This P will laterally invert because that is the first thing you will see and will look like 9. A will still look like A, M will still look like M. So look at what just happened. Because of the presence of the mirror, map has changed to what? 9 AM. This is what we call lateral inversion. So imagine I have something, let's say I I write the word cats in front of my mirror. Let's see what is going to happen. T will not change, A will not change, but C becomes K like this. So you see, you have something else. So this is lateral what? Inversion. So you can practice with your name. So I can write my name in front of a mirror and see what is going to be observed. So look at my name, Prime. This is Prime. And I write this in front of the mirror. Let me see what is going to happen. So E becomes this. This is how E will look like. M is still M. I is still I. R becomes something. R will now looks like this. And then this P becomes 9. You see, I did not even recognize my name again. So this is what we call lateral what? Inversion. So you can practice with your own name and see how it is going to appear in front of a mirror. So these are the properties of the images formed by what? By plane mirrors. Now the